Hello guys, this is Giovanni Di Grezia. Today I'm showing you two useful scripts. I think that they are useful. And this is a sample project in 3dqualizer 4. And today you will see fill 2D and fill 3D. What are the aims of these scripts? So let's start. We have a simple scene here, a normal camera with parallax, and we have some tracked points. Okay, let's start. Fill 2D has two options: average each 2D point 2D and average each 2D point 2D with distortion. The menu is divided into two parts, 2D and 3D, because the fill 2D parts main is related to 2D curves and their tracking points on manual tracking, and fill 3D is related to 3D points, but we use this menu in manual tracking because we can also visualize here 3D points, and we can show, for example, the deviation between the 3D points and the corresponding 2D points. So I put them both in this window. The fill 2D is average each 2D points. It's simple. Let me hide the 3D points for a second. For example, here we have 2 points on one end and on the other end of the corner of this door. If we select 2 points, 2D points, and we press average each 2D point 2D, automatically we create in the selected camera and in selected point group a new point, and this point is called average 4041 because it's the name of 2 original points. And we have here another point tracked only between the visible 2D points of original selected points. So we can see this point is available only because these 2D points are here. For example, if we select another point that go out of frame, for example this one, we can do an average between these 2D points, and we can see that the new created point, an average between 0, 1 and 40, now it's visible only until the last frame visible of both. For example, the frame 350, they are both present, and the next frame, the 0, 1, isn't visible, so we can calculate the 2D average. And so we have a little nice tool to calculate the 2D points. This version is also a normal average, because we can calculate this and this point, and mathematically we calculate the mid distance between the 2 points. But there is also, if these points are on the same usually 2D planes and the camera has been tracked in the right way, we can do we can take this point. We can also make an average with distortion. The script will undistort this point based on the 3D based on distortion lens actually applied on the camera, and undistort also this point, and after that it will calculate the midpoint, and on this point it will calculate the distortion. So undistort this point and this point, he calculates the midpoint and apply the distortion on this point. So if you click the 3D points with distortion, it will do exactly what I said. And we have a new point that in this case is they are really similar, but there are some differences. So it may be useful because the 2D points mid is not very accurate when you have a camera with a lot of distortions, because these tracked points are tracked based on the distortion of the camera. So the best way to calculate an average point is to track this point and after that resolve camera in right way with focal length and with distortion based on the grid or no distortion, and after that you should use the 2D points with distortion, because it will undistort the first and the second point, like if there wasn't any distortion in the camera, and after that calculate the mid and reapply distortion to this point. An important thing to consider is that the 2D point, the mid, the average 2D points, isn't always the real 2D points, the midpoint between two tracked points in 3D space. What does it mean? If we have these 2 points, we think that this midpoint should be also in 3D. So during this tracked point, we should see a solid point fixed on a particular pattern or on a feature, but we can see that these 2 points are tracked correctly because they are in the mid of this hole, and this point here is pretty stable because it's on the corner of the door. But if we give a look to the mid, one of 2, because in this case the distortion isn't very important, we can see that this point isn't on the real center between these 2 points. This is because when we have parallax shift, the midpoint between the mid 3D point between 2D tracked point isn't the midpoint in 2D space between 2 of them, because when we change the perspective of the scene, usually the far part, the part more distant from us, has a little segment. So the distance between this point and this point in real world is lesser than this and this point, because if the first point of the segment is near to us and the second point is far from us, the midpoint is slightly moved towards the far way, because in perspective things in the far distance are very little respect of what is near to us. So you can see that the average is usually useful when you have difficult shots or when you need a difficult point between 2 already tracked points with no pattern inside. But in this case, the parallax is changing the midpoint. So if you track this point and you resolve the camera right now, you can see that the point is moving along the mid position, so it isn't accurate. And we can see this after. Now, right now, we have already solved this camera, and we have 3D points with distortion. And you can see that these 3D points are this point and this point are pretty stable. Now we can use the fill 3D commands, and we have different options, but the core is the same. Here the basic is average each 2 points 3D. If we select 2 3D points, we can press average each 2D points 3D, and we create an average 3D point. You can see the name here, between 0.01 and 40, and we have a new point. Let me delete the previous one. The new point is a point with no 2D track, so it's only present into 3D space. The point, this one. The problem is that if you don't want to calculate again from scratch, and this is your final stage of match moving, you can leave in this way, because there are no problem. We can select also 3 of them, and we can reapply average each 2D points 3D, and so we have also the midpoint between them, and all these points are only in 3D space. We can see them here. These are useful, but if we calculate again from scratch, these points are gone, because we don't have we don't have 3D, we don't have 2D curves. So if you are at the end, it can be useful, but otherwise we can use also the average 2D points with reline. We have the reline, normal reline, and reline with distortion. The reline with the normal reline will only reline the points, not considering the distortion of the footage, while the other one, the reline with distortion, will calculate 3D points as before, and after that it will reel in the 2D points, back projecting onto the footage, considering the distortion of the camera. Let's try this. Now we have the 3D points into space, and we have also the 2D tracks. We can see the red point. So if we resolve now the shot, obviously the deviation of this point and 3D points is 0, because we are creating something artificial, in artificial way, so it will be precisely with at 0 deviation. But the objective is that if you make other movements to the shots, other things, I don't know what you are going to do, and you calculate things from scratch, you can always have this point, because you have also a tracked 2D curves. A problem here is that if you see the reline calculate all on the entire duration of the shot. Let's try this on another point. For example, a point that goes outside of view. We can select, for example, these 2D points. There are also some of these points are incorrect because are only some tests made it. So if we do this here, average each 3D points with reline distortion, we have this new point, and we can see that now the 2D tracks is also tracked outside, because the 3D point is in 3D space, so he can backtrace also into the outside the FOV, but we don't want this every time, because it can be useful in some shots. If you want a valid keyframe also outside, you can select here valid always, or inside the frame, or inside the FOV only. This is in your shows. But if you don't want these tracks outside, you should delete them manually using the Windows Cure editor, the timeline editor, and here you can delete what is out. But there is also another approach, that you can select points and do the average 2D 2.3D rail-in only in a visible frame with distortion. And doing this, now you have only 2D points until the end of the frame. The 3 points is always in 3D, so it will be always visible outside the frame. But now you have only the 2D the 2D tracks inside. Okay, we have done also this. So we covered the 2D and fill 3D points, and the same commands are also available into the reconstruction panel. The reconstruction panel will be covered in another tutorial. Now you can see, for example, in here, that if we do an average 2D points, remember also that this script works with, and these scripts works with a different number of points. So if you select, for example, 3 of them, you can do the average each 2D points. So it will do exactly, it will add a point here and a point here, and also a point between here and here, because it will do the mid between each. It will create, using combination, all possible couples, because we have 3 points here. So we have 1, 2, and 3 couples. So we create 3 points. We can delete, for example, this one, but we have under 2. If we select all of them, we can create all points inside all possible combinations. And this is the same also for 3D. Average each, the word each is each couple. Now we can see the difference between the fill 2D and 3D, and why you shouldn't use the average each 2D points 2D always, because they aren't really exact. If we do an average 2D with distortion, we have this, and we can see that this isn't centered. If you select this one and we create an average each 2D points 3D rail-in invisible with distortion, now we have another point. We can see that creating a 3D point using the new tool, the tool with fill 3D, we can have a more stable position. Now this isn't very accurate, because this is only a shot for tests, but you can see that you can triangulate using 2 3D points, and after that using the rail-in feature. So you can have a stable. You can see his point is shifting, so for this purpose you see that this point also is shifting at the end. But in this part, for example, between these frames where this point and this point are correctly tracked, you can see that the midpoint is right. So we have a 3D point and also a 2D really tracked point with a right position. And you can see that 2D points here, the average 2D points fails because it's shifting. This is because in this shot the parallax is moved again towards this point, and moving and rotating it will go to the mid and after that towards this point. So be careful, because you should use the field 2D only when you have a flat or a front shot, or in some for example when you have to track something that's zero is really it's in the mid of two really close points. But the field 3D points will help you to create 3D new 3D point. For example, if you need new 3D points and you can't have you can track a point in the mid, and you can check also the results here. You can also see if the both hands of the 3D points are truly tracked in they are good points, because you can see that the midpoint 3D point should be also stable, but here at the end this point is not, is shifting a bit. And the fact it's shifting a bit because this 3D point is shifting. So let's consider this when you use these tools. Usually the field 2D is only a 2D average with distortion between 2 points. The field 3D is more accurate because you should have already created 3D points, and after the mid position you should reel in using the distortion of 2D footage. I think this is all. I hope that I explained it at least at minimum level with my bad English. And so this is all. In the next tutorials I will cover reconstruction and also some pass and deformation keys and some adjustment on 2D curves using Fourier. You will find an install instruction in the description, also the GitHub link or the Bitbucket link, and if you have any issue, problem, please let me know, send me an email or opening an issue online. Thank you very much for your attention.